All right, I believe that Samir will be joining us shortly. We're going to be talking about Confederacy in this video. We're going to be describing some of its core capabilities and some of the ways that it's going to enable new types of applications to be built on top of the BSV blockchain. So this includes particularly UTXO-based overlay networks and methods for solving the back to Genesis problem. So Confederacy is a system that has been the result of many years of research and development, including a couple of iterations. The previous iteration of the system was called Bridgeport, which was a more open-ended approach, but it didn't use UTXOs. So the advantage of using UTXOs, and here he is. All right. Hello, Samir.
Hello. Hi. Can you hear me?
Yes, I can. Good to
Okay,
good to see you. It's been a little while.
yeah, it's been. How's it going? I was going through some of your videos. Not all of them, but some of them. They're pretty cool. Um, yeah. So
Yeah, we've been doing a lot recently, just putting out content, letting people know about how all of these things are supposed to work, right? And
sure.
then hopefully that leads to better ways of building on BSV and doing things the most scalable and efficient way.
Yep. Yeah.
Um, I mean, I think that a lot of technology is just trying to figure out what the right approach is and then come to an agreement on that approach so that everybody involved can,
Yep.
understand the best thing. Like, in the early days of the internet, it was hard because we didn't know how we should solve things like how can a browser talk to a server, right? How can
Yep.
different browsers made by different people talk to the same server?
Yep.
Um,
Yeah.
and all
Yeah.
these silly things. And so hopefully we can get to the same point with Bitcoin here where maybe people can come to an agreement about how can an application talk to a user? What is user identity?
Yeah.
All these things.
Yeah. I think there's a class. Did you? I attended the conference. I don't know, the workshop that the Craig
hmm.
had. I think last week or two
Was it the
weeks ago.
Bitcoin masterclass?
Yeah, the master class. Yeah, the two day workshop. And
Okay.
there's one coming up next week, or the week after, that is talking about IP to IP, and
hmm
multicasting and those kind of things. So I'm kind of interested on that because like uh, you know my team, the the robotics team. So I'm trying to start educating them about these kind of things, for IoT devices and so forth. So I have a call with them tomorrow. These kind of things. So I'm kind of curious to talk, learn about that next week, from the workshop, see what he has to say. But like you mentioned, about
Confederacy.
Confederacy. Yeah. So that's a new word that I'm hearing in this
hmm
space. So what is that? Uh, what?
Essentially, it's a way of having an overlay network on
Okay.
Bitcoin.
Yeah.
And then, so you have transactions, right? And the transactions are sent. It's not like forced. It's not like everybody has to have all the transactions, but they're sent between people who might be interested. Um, so in Confederacy, there's topics, and each topic is like a topic in, Usenet, which is old. It's a way of sending information. You could think of it like a channel in Slack or something, where
Yep.
each topic is essentially a way of exchanging messages. Uh, so in Confederacy, there's these things called topics, and each topic is related to a specific, overlay network, basically. And
Mm-hmm.
then
Mm-hmm.
there's a mechanism for different people to pop up and synchronize, basically Bitcoin transaction outputs that are
Yep.
that are related to a particular topic.
Topic. Okay.
So to run an overlay network with Confederacy, people have to create Bitcoin transactions that follow the rules for a particular topic, and then send that transaction to one or many different Confederacy hosts or nodes on the overlay network that that will share the new transaction and the new output script inside that transaction that complies with the topic to everyone else. And that way, the state of the overlay network is synchronized within a Bitcoin transaction output in a UTXO, right?
Okay. Yeah. So that makes sense. I mean, that's I think that should be the design of the overlay networks. Like, you have a topic or whatever, whatever,
A particular
however.
type of data.
Yeah, a particular type of data. But anybody who's interested on that type of data will run their, will have the option to run their own node, but yet be, synchronized regardless of who receives a new transaction regarding that topic in the network.
Yeah.
Yeah. So
and then some people, like some
Yep.
people can run, some topics, and other people can run other ones, and there's no real hard requirement that every message, even in a given topic, is sent to every person, because a person could only want, like, suppose there's a topic for songs.
Yep.
But it's like, I don't want all songs. I only want the songs that I like,
Yep.
So I get some songs, and then if they ever get updated, the ones that I have, I would know, because if I try to spend a UTXO and it's already been spent by somebody else, someone's already updated it, then I can't do it because it's a double spend. So that means I stay updated about only the things that I need to, and I only have the ones that I need. But if I'm a big company that runs like a song service, a music service, then maybe I try to have most things most of the time, and then allow people to search, so yeah, there's more detail with topics. There's different, like, components of a topic. There's a topic manager that manages what can be in a topic. And then there's a lookup service, which allows people to sort through all the different things they have in a particular topic, to allow applications to, to query different, like, things, maybe their songs, maybe their messages, maybe their posts on a forum, something like that. And then there's synchronizers, which are going to synchronize the, and those aren't built yet in my implementation yet, but they will be, that synchronize particular things from a topic to other, hosts who also care about that type of information. So in that way, we can have applications that define rules for how data is to be exchanged, and then apply those rules via Confederacy topics and build overlays that exchange, Bitcoin transaction outputs that change the state of particular overlay networks. And then anybody can join or leave that network at will, and then people pay. So there's a system called packet pay that is used with Confederacy, and packet pay allows people to pay for, when you want to submit a new transaction into the topic, or when you want to read all the transactions. Like, if I ask for 1 million transactions and you just have them, you shouldn't give them to me for free. So payment is integrated in, and that payment uses full SPV so that you can verify all the payments and everything like that. So packet pay is useful for doing, payments for this type of data.
Sure. So there are two aspects of this, right? So there is the miner aspect of it, who validate the Bitcoin transaction, and there is the type of data, which is probably would be either up push, transaction, or some of those, few of those different
methods for putting
operations.
data.
Putting data. So that the validation of that data and synchronization of that data with other, like the nodes that is specifically interested on this kind of data, also need to be incentivized to run the node, just like how, like how when Bitcoin first came about, they were validating the Bitcoin transaction, and so Satoshi first ran the node, and then the second was like maybe Halfany, or maybe there were other people. So there was some kind of incentive for them to run that node, because they were earning some payment, which in the form of Bitcoin, which they thought was valuable. Of course, the protocol was valuable, but then from a monetary standpoint, there is money that they would receive for as a form of reward for running a node and validating the Bitcoin transactions. Just like that, similarly, on this different type of overlay network, which would be different type of topic data, the validation of the data itself has to have some form of reward. So that reward is how, what would be the for me, like I'm not thinking from a different token, a brand new token, but I'm thinking from a Bitcoin itself, but integrated on that payment. So how would that work? Like, what do you think would work on those overlay? Like, for example, for me independently, okay, so tomorrow, let's say there is a type of data called name, like we were talking about key value, like in a form, like there's a type of data called name, which could be a node in itself, which stores all the names, and pretty much any name, all the names with the standard key of a type data name. And why would somebody else run that node? And there has to be some kind of reward incentive mechanism in the form of Bitcoins. How would that work? Like, what do you think would how would that work in
Yeah.
these overlay networks?
So how this would work is when people make queries or requests to read data from an overlay network node, then they pay. So Packet Pay is a system that allows for you to basically transparently pay for any API request. So if you run a server of any kind, you can just pay directly using Bitcoin. The payment is verified with SPV. All the input transactions are provided, including the Merkle paths on them, and everything is verified through the payment. And that happens transparently. So no one really has to think about that. It just, here's the price of the request, we approve it, and then the request happens. And then so this applies on a lower layer than Confederacy. On the transport layer, effectively, is what it really is. It's a way of getting data from one place to another, where it's paid for. And so Confederacy can decide to monetize its own data that it has, and the queries that people can make against that data. So there's no way that it's always going to be viable. But if the particular overlay network node who's hosting a particular thing is doing something useful for somebody, then that somebody will be able to query that node. So for example, if I'm an application and I want to know somebody's name from the name overlay network in your example, then what can happen is I can just pay the name over. I can pick some node that I want to use from the name overlay network, and I will pay that node to provide me the information that I need via using queries and using the topic the lookup services. So then the overlay network node that I'm communicating with, the Confederacy instance, will search through its set of synchronized data, and using its lookup service, provide the data back to the requester, and the requester pays for that information. So with that being said, that's how the architecture would work. It's just a matter of figuring out what is going to be the sort of the utility of a particular node in a particular context. So some nodes might be more useful than others, and therefore they would make more money than others. If I just run a node because I think it's cool to validate everything myself, even though I don't have any economic reason to do so, then I might not be able to cover the cost of my running this node because I'm not providing a useful service to anybody else. And we have to, as businesses, provide useful, goods and services to other people so that we can earn revenue.
Yep, absolutely. So like, for example, going back to the name example, right? So because the reason why I'm asking this is for us to have a global name, like maybe a DNS server or
some overlay network that allows that type of resolution.
And yeah, like even Paymail. So where say Paymail that has been the set of protocols that has been built. Why would somebody, there has to be some kind of incentive for somebody else to run a Paymail server that allows for them to identify themselves as as some kind of name, or just using the same example as a DNS, like say the DNS server. Why would somebody use that DNS servers versus some other DNS server within the network, right? So what would make an overlay network more attractive versus another overlay network? So I think these kind of things have to be probably figure out in terms from a protocol standpoint, to make it attractive. So,
So on a protocol
what do you
level,
think about?
yeah.
Yeah.
On a protocol level, the payment is applied on the communications layer between nodes on the overlay network. So if I have two choices, I can use a network node that Samir operates, or I can use a network node that Tai operates. Then
Yep.
if mine does the same thing as yours and has the same data, and if mine is more expensive, then somebody will choose to use yours because they want to pay less. But if yours, while it might be cheaper, if it still has less information than mine, then somebody would want to use my node instead because it is more it provides more value in the particular context. So just like in capitalism itself, where there are different competing entities who have different interests and they provide different quality of products as well as different price points for their products. The same applies to particular overlay network nodes who host particular topics of UTXO within the station within the network itself. And so I should choose, if I'm an application developer writing an application who needs to interface with an overlay network, I should choose nodes that are going to reliably provide the data that I need while doing so at the lowest cost. And so developers have an incentive to make that choice effectively so that the economic efficiency of their applications is maximized, and they're not degrading the user experience by being too cheap, and they're also not paying too much for some services which they may not need, or by using an overpriced node. And so by finding a middle ground, it allows for the application to be a more economically efficient business. And thus, when the application is a more economically efficient business, they have a greater opportunity to offer the services of the application itself at a lower price to their end users, thus increasing the attractiveness of their offering as an application in the marketplace. And those are the incentives that drive people towards efficient models for overlay networks, as well as create competition between different lookup services, proprietary implementations of lookup services, and encourage competing overlay networks to, or competing overlay network operators rather, to synchronize state, and that way people have access to the most information possible at the lowest cost possible.
Yep. So from a synchronization perspective, like say for example, if I'm offering a name node service, and you are offering the name node service, so the idea behind, like in Bitcoin, there's this thing called small world network, where the miners, regardless of who mines a block, everybody, they have to broadcast the block to, so that everybody is synchronized and at the same level, so that they can start continuing to receiving the new rewards, or new new transactions for new rewards. So just like that in the within the overlay network. So the synchronization mechanism, why would I synchronize with your node, as as say for example, just again giving a name node. Why would I synchronize with your node versus if I have a network of users that I have already established, that I can service through my node, what's an incentive for me to join or be part of your to be part of your node, and maybe because what if the users that I have start using your node, if I bring those users that I've already tied through whatever MOUs or whatever whatever I've done in providing the services. If I start synchronizing with your node, then there is a risk that those users will go to your node, and I lose the revenue off of those users. So what's
really,
I know Bitcoin really solves it in a very unique way, but in the overlay network, I think it's going to be really challenging to solve that. If we can use the same protocol that Bitcoin does. So
it really
how would we
comes
do
back
that?
to game theory, I suppose, right? So when we think of these overlay networks, just like the game between Bitcoin miners, it's a multi-leader and multi-follower Steckelberg game. right? And this means that you have big miners and you have small miners. And so let's just categorize the network nodes on the overlay network as we have big network nodes and small network nodes. If I'm a big network node, then, well, actually, let's think of the small network node first. It'll be easier. So if we think of the small network node, I am willing to pay a big network node to synchronize me some data. So suppose it costs me $200,000 to, so suppose I want to make a competitor to think of songs. Like there's a Pandora node and there's a Spotify node on the songs overlay network. And they're big nodes. And then I'm a small node and I want to compete with them. So I start the tempo node, and now I want to synchronize songs. So the cost for me to do this is I have to pay because, if I want to learn about 5 million songs, then I have to synchronize with these two nodes, and the cost of doing that, I'll need to pay maybe $100,000, right?
Mm-hmm.
And it makes sense. I should invest in doing this because I believe that I have a product that is useful and I would like to run my own infrastructure so I'm not relying on other people. So therefore, it makes economic sense for me to pay this amount. But this doesn't address the real problem. If a big node receives a request from a small node for synchronizing, why would the big node ever pay for that request? And the answer is that in a multi-leader and multi-follower game, the big node would actually want to make this money, because if he doesn't, then the small node will go to some other big node and synchronize, and then he'll lose out on the money. So if I have an offer to synchronize somebody, and I believe that the amount of money that I'm receiving from this is going to give me an advantage compared to other big nodes, then I should accept this money, because otherwise he will go to someone else and he will then synchronize the same data and I will lose out on the reward that I was offered. And so if the reward is too big, then the small node will lose because he's paying a lot of money that he doesn't need to pay. And also the small node will lose because he could get a better deal by going to some other big node. However, if the reward is too small, then the small node is winning, but the big node is losing because he could demand more. It's a question of whether he believes the small node would be willing to go to some other person to synchronize the majority of the data, and versus just only going to his own self. And so because of this, it makes sense for some big node to synchronize. It's like the prisoner's dilemma, unless everybody doesn't synchronize the small node, then somebody will, and the person who does will win the most. And if you think about it, the more people that participate in this refusal, the greater the payoff for the one person who does not participate. So for example, if there are 10 big nodes and 20 small nodes, and suppose 8 of the big nodes are refusing to synchronize the small node, right? Then the small node is willing to pay a lot more money for synchronization because he's been refused by 8 different people. So he'll go to the final person, and number 9 will see this enormous offer. And the chances that number 9 will see a greater benefit in synchronizing the small node increase compared to going with the pact, with the other 8. So the 9th node in the list would have a significantly high amount of pressure on synchronizing, because the amount of money that he would receive is much more. And so therefore, it doesn't make sense for the 8 people to give node number 9 a giant advantage by making this service much more valuable by their refusal to synchronize. And therefore, when you think of it from a game theoretic perspective, nodes have an incentive to synchronize one another if they believe that other nodes will not, or if they believe that the other nodes will, in both cases, actually. If a node believes that a competing node is not going to synchronize the other node, then the node should be willing to negotiate a higher price with the node that wants to be synchronized. And if a node believes that the competing nodes will synchronize, then the node with the offer should be willing to accept the offer or even offer a lower price than the price offered by other nodes that could perform this, that could facilitate the synchronization by the small node, or for the small node rather. And therefore, we have a system that encourages the sharing of information between nodes so that they become updated with the latest information if they're willing to make what the market and the game deems to be a reasonable investment in synchronizing with the rest of the network. And that investment actually acts as a demonstration of the loss of opportunity cost that could be used in the future to, for example, attack the network, and increases the security and robustness of the network as well.
Yeah, absolutely. I think yeah, that makes sense. So this overlay, the incentive for the overlay networks to synchronize and be able and be at the same state at all times, and trying to receive new, I will say new transaction to add to the list of services
of UTXOs,
of UTXOs would definitely be have greater value at the end of the day. So yeah, we would still use from a monetary standpoint, because right now I'm thinking Bitcoin as money. We're talking about the efficiency and these kind of advantages of synchronization, like being able to service more customers, because if there are multiple, say for example Spotify and because like right now the business models of Spotify and Pandora and Apple Music, they really don't want to sync. There is no incentive for them to sync. It's like they have different siloed businesses and siloed customers, and they subscribe to their own specific loyal users. But now with this model, with the new model where everybody is synced, and there's a business it's driven from a business standpoint for them to sync, from a monetary standpoint, as well as for being able to service customers more efficiently. Because now imagine, like, I as a Spotify user, imagine if I could open up my Apple Music and still be able to find all of my music on Apple Music. Would open up so many opportunities for the users, just from efficiency standpoint, right? So that is the driving factor for the users. But from a business standpoint, for these businesses like Spotify and Apple Music, for them to be not remain siloed but synchronized into a one small world network, would open up a lot more profit motive, would be definitely it would definitely make sense. But from a monetary standpoint, how would that work to the businesses for them to synchronize? How would they be making money versus what they're doing right now? Is it because of the fundamental principle behind the money has changed, or why would they do that, right?
You have micropayments on every interaction now. Whenever someone reads data from your overlay network, you make money from that. Whenever somebody puts new data into your overlay network by creating a Bitcoin transaction, you can make money from that if you're the one that receives it first. And so you can, when you synchronize everything, you make it so that your node is more valuable. When you learn information from other nodes, when you make that investment and pay those other nodes to form agreements with you and give you the information that they learn, then people are willing to use your node because you have that information now. And then you can use your own proprietary search algorithms and things like this to provide it to them in the most effective way for them, but for the user. But you learn about and have access to more information, and thus there's a federated model by which information is exchanged between network participants. And the investment made by network participants in obtaining data from other network participants pays off, because now they can provide their value-added service more competitively, and the users are paying for that directly.
Yep. Okay. So yeah, I see your point. So and I'm still like because the concept of MAPI that was introduced in Bitcoin,
Minor API,
where
yes, or
yeah, the
merchant
minor
API,
API, merchant
MAPI, yeah.
API, where yeah, so where a user was tied, if they have a good relationship with a miner, they can broadcast, they can use them to broadcast their transactions, and the miners, it's miners' responsibility to broadcast, you know, that transaction to the rest of the nodes, just use on the protocol level. But now these and there's some kind of incentive for them to do that, but within the overlay network, right? So for example, if I'm using your name, like Ty's node, name node, uh, and if your node is very efficient, and all the users go through your node, and you have a brilliant UI and all that, all that thing,
Mhm.
you know, uh, I'm still trying to understand, from a Bitcoin's protocol to be applied to these overlay networks protocol, where Ty's node is incentivized to share your features and your to the other node within the network, and
Mhm.
potentially lose the customers that you've already tied to.
Mm.
And I think
Well,
that is still
the
that is
more
still it.
valuable, the more data I have, the more customers I have, the more data, the more transactions that I have on my overlay network node, the more people are willing to pay to access it. And thus, I get more money the more value I add for my users. Not only from the
Yes.
users, but also from people who pay me so they can synchronize. And if they are paying so much because their user experience is so bad compared to mine, then other users are not moving over to their platform because their UI is not as good. And if their UI is not as good, then they should need to pay for the privilege of accessing data.
Mm,
Where in this context, the overlay itself is the mechanism by which the data is, or the value of the data is enforced by the market.
mhm.
And what this means is if your UI sucks, then you have two options. Number one, you can make your UI better, and therefore more people will use your network, and therefore you will have more data. And
Yep.
therefore you can pay for these things, or you can pay less to other people because you don't need to synchronize as much with them, because now maybe they need to synchronize with you. If you're
Yeah.
big, people pay you to have access to data, and you make money from this. But
Yep.
if your UI is terrible, then less people will use your system. What this enables is people will create more UIs that are better, and then gain data when users come onto that system. And if so, then the investment that was originally made in needing to synchronize data from the pre-existing players in the game,
Mhm.
now that investment is paid off, because now the other players who have lost users, they will have to pay me if my UI is better. But as
Yep.
somebody who has a good UI, I can make a lot of money by synchronizing with people who have worse UIs
Yep.
because they
Yep.
have to pay me. And therefore, the better my UI, the more money I am going to make, because the more data that is generated by my user experience as
Mhm.
a competitive user experience to other systems
Yep.
that have to
I
pay, to synchronize.
Yeah, yeah. I think Bitcoin, like at least from the mining, the Bitcoin protocol works in a little bit different way, regardless. Like say for example, Jungle Bus, or
Oh, they use
Gorilla,
chain scanning. Yeah,
yeah,
yeah.
the let's say Gorilla Pool as a miner,
Mhm.
regardless of say within a block, right? So in a block, they receive all the transactions is all by received
Mhm.
by Gorilla Pool, right? And they are the ones who receive the transactions, but and they are the ones who broadcast to the rest of the miners. And
Yeah.
but but at the same time, let's say all the users are tied to Gorilla Pools via the MAPI, and they you know uh, let's say in a block, in a 10-minute block, all the transactions that have happened is via say Gorilla Pool, right? But within the Bitcoin network, it doesn't matter which miner receives the transaction.
Right.
Anybody else, like say Nchain or Tal or whatever, whoever is, the other miners, they are able to earn the reward, regardless of, because it's a random, of course there's a hash power involved and all, but the reward mechanism is open for anybody to grab, regardless of
Mhm.
who has the strongest user connection, because that's how the protocol works, right? Because the reward is like I said, if there are 10,000 users that have broadcasted a transaction, say 10,000 transactions to Gorilla via the Gorilla Pool MAPI, but and Gorilla Pool is the one who have broadcasted these transactions to the rest of the nodes, but the block creation, that's the solution, whoever finds that solution is the one who will earn the reward. It doesn't have to be Gorilla Pool, even though they are the ones who are bringing all the businesses. But in the overlay network, how can we? Because and I think that's really key for Bitcoin's protocol to be secure. Having that synchronization, having everybody yet distributed, but that freedom to earn is that advantage. So would we make the overlay network as from a protocol standpoint, just like that, because think about it for a second, because right now if your UI is the best, if your node is the best, and of course you would want to keep all the rewards that your users have. Why would I do all the hard work and let somebody who is just who just runs a node, just running a node and earn the reward. So that kind of that kind of business mind process from a profit standpoint would automatically come. But how would we ensure that the protocol like Bitcoin, how the Bitcoin is using in to solve the mining problem would we use in the overlay network? So that is something that I'm still having hard time understanding, to apply on the overlay network, because that is really key for us to start moving into that layer. You know what I mean?
Yeah.
Does that make sense?
So the mechanism and the game theory that I described when I was originally talking about how the incentives of the overlay networks operate also applies to the lower layers of Bitcoin and mining itself. So
Sure.
when the Bitcoin miners mine a block, they're engaging in this game as well, where every miner has an incentive to synchronize the transactions they learn about with other miners, so that if they find the block, then they will be rewarded. Because the orphan rate is less when more miners know about more transactions. And as a miner, you don't want to increase the propagation time of your blocks to other miners. And therefore, you share all of the transactions to the other miners immediately. At least that's the incentive, unless you're receiving some other incentive that would subsidize the risk of orphans for long propagation times on your blocks if you're holding things privately. But that's a different matter. In this context, the overlays, the overlay network operators make money by doing things that are valuable to the users of the overlay network, just like the Bitcoin miners make money by doing things that are valuable to all users of Bitcoin, which are those who create Bitcoin transactions and seek to accept them into blocks via transaction fees. So in the overlays, the value of each overlay network is defined differently by its users, but the users compensate the overlay network operators for value by paying to include transactions into the overlay network upon transaction submission, or by paying to look up and read information from the overlay network in the same context. And it looks like there's a prompt on this Zoom meeting indicating it will end soon. So if that happens, then we'll, how long have we been going? Like 40 minutes, I guess?
Yeah, it's been 40 minutes. Yeah, 38 minutes. Yeah.
Wow. Okay. Well, we can, yeah, I think see, now I lost my train of thought. This is why we need micropayments for video calls, because then Zoom will not interrupt. I thought that two-person meetings would be less sort of restricted than group meetings, but I guess they changed it because
like
they like money.
on the overlay, the reward that I think what you're saying was on the reward that the users have paid for a service that overlay provides. Because we're not talking about one node within the overlay, we're talking about distributed, just like how Bitcoin started. We want to create a distributed overlay that anybody can run a node and start earning the reward. What I'm curious about is a user that has this reward, is up for grabs for any node, regardless of if they join, to make a robust small world overlay network. I think that protocol, there has to be some kind of economic incentive, driven protocol for maybe an open source, something like that,
Yeah.
to drive this to so that anybody can run a node, and
Well,
regardless of if
really,
you've
yeah. What it
yeah
comes
see what I
down
mean?
to is you have to create value for the users of a particular overlay network. And
Yeah,
the way to do that is by creating user interfaces that creating systems that add value to the users of that network so that the users of that network can pay for things and can do things that benefit the overlay network operators enough to keep them operating it. I think we'll come back after this meeting is ending, Samir.
Sure.
So thank you for this one. I think we'll make this part 1, and we'll come back for part 2 of this video. So
Yeah,
thank you
sure,
guys for watching.
Yeah, bye.